Hello folks, fellow YouTubers and friends, and welcome once again to Boomtown Laboratories, where we are super dedicated to the research and development of the Milkovic two-stage oscillator. Haven't made a video of this machine in quite some time, but that does not mean that we have not been working on it. And we have made great progress, unbelievable progress. The last video I made of this machine, we had a big tower over here with a 10-part line block and tackle with weights, and it was hanging up, and we found out why. It wasn't the pulleys, it was the used bicycle parts. So we've done away with all of that. And everything we do now as far as bearings and sprockets and chains are all new. In fact, the double Beckett that we had was working fine until another upgrade we did. We took the steel shot out of the pendulum and put lead in it. This pendulum now weighs 375 pounds, swinging at from pivot point to center of pendulum 6 feet 6 inches, which is within a fraction of an inch, 2 meters. Now, another improvement we made is when we put the lead in, the double Beckett we had was almost ripping the bicycle chain in two. So we went to a Schedule 41 chain and new sprockets. We got this gearbox, my buddy calls it a jack shaft because it jacks speed up and jacks it down. But we got this off of a job, and we've replaced bearings in it, cleaned the chain up a little bit, and this, that, and other. So what we have here is from the lifting of the Beckett, it pulls the chain up on this side and pulls it down on that side. So as this goes up and down, the chain is constantly going in the same direction, and this all here constitutes a 6-to-1 ratio. Okay, so if this turns one time, this turns 6 times. This is 8 inches in diameter. This sprocket is 9 inches in diameter. I know it's jacking it down a little bit, but we're getting ready to put an 8-inch sprocket on this. This is the Windy Nation PMA that I told you about in an earlier video. When the pendulum is working at full throttle, it's putting out somewhere between 11.5 to 12 volts. Dummy me, we didn't measure the amperage it's putting out. And it's taking less than 80, well actually less than 90 inch-pounds of energy to power the pendulum completely in a circle. When you do in a circle up there, then the pendulum actually makes a pull twice. So the work bar weighs 50 pounds, but it is capable of lifting 100. So therefore, when it comes up with a 50-pound force for 6 inches, and then it comes down with a 50-pound force for 6 inches. So that's 200 foot-pounds, or 2,400 inch-pounds. However, it only takes 90 inch-pounds, about 2 pounds on that 14-inch pulley up there, which is 44 inches around. 2 times 44 is 88, so it takes 88 inch-pounds, roughly, to power it, and it puts out 2,400 inch-pounds of force, constant, driving this PMA. Okay? In powering this thing by hand, the machine is so powerful, the slightest little wiggle and it throws things off. So we had to put these braces on. We're putting them on today, and to keep it from wiggling. Plus, well, this is a new apparatus that we developed and built, and it's our rack and pinion gear, and this keeps that thing going straight, and it works like a champ. Now, over here, if you look, we have an all-thread rod going into an all-thread rod coupling inside of a piece of EMT conduit. And that's so that we can adjust the length. We don't have it exact yet, because when this comes around, on this side it takes a little bit more power just to break through, but on this side it comes through real easy, real easy. So that's our update, folks, and I will be making more videos very soon as we get this thing powered up again. Okay, thank you very much for watching.